So there are some factors that affect air pollution, and they can increase or decrease. So let's start with what factors can decrease air pollution. Try to look at the visuals to guide you. No. That would increase, I guess. I'm sorry? Wind. Good job. Ocean or sea spray. Rain in cleansing, which is right here. Precipitation will help, like water is a universal solvent. It helps sometimes dilute, right? Or change the reaction. Speaking of reactions, I'll just expose this one. Chemical reactions in general can decrease air pollution. And finish that sentence. If a particle is blank, it settles due to gravity. Heavy, good. So any particle or pollutant in particulate matter that's heavy, or a compound that's heavier than air, can come back down to the ground, so it's no longer air pollution. Factors that increase air pollution. Okay, really high temperatures can promote chemical reactions that'll lead to increase in pollution. What else? Look at that picture. Not just altitude. What? Urbanization is definitely one. So what does this picture have to do with, like, have in common with this one? Nope. Yes, it's the mountains or hills. They will trap pollutants. So the same way buildings will cause pollution to stay stagnant in a specific area. So, and with urbanization, there's also the loss of greenery and the increase of cement that aids in pollution not being able to dilute or move freely. The same thing happens with hills and mountains. And I'll show you a video in a minute. Now, volatile organic compounds from certain trees like oak and kudzu have led to an increase in pollution. Do you guys know about the kudzu? What do you know about it? Native or non-native? Non-native. Okay, which means what? It was brought in from somewhere. What else? Do you know about non-native? We call them what? Invasive or alien or one more. Exotic. What do we know about them that's bad? They don't have any natural predators. So this vine just keeps, it's like out of control growth. It has overpopulated and it's taken over. We're going to get a little bit more into that when we do the case studies. And then we also have this thing called the grasshopper effect. And this is like a vocab word, which I did a poor job in defining, but I'm going to read it to you. Basically, pollutants, that should say when pollutants are, as in ARE, transported from the tropical regions to the polar regions, is called the grasshopper effect. And because it's going from like warmer temperature to colder temperatures, it shouldn't be there, and that's a problem. And just like temperature inversions, which I'm going to talk about both of those in a minute. So normal temperature in our lower atmosphere should be hot, flowing to cool. You don't really have to know cool to cold, but you know molecules move from hot to cold. So if the atmosphere's temperature is correct, then the pollutants will travel beyond the troposphere or dilute as they go up. When you have temperature inversions, you have a warm layer above the cool layer or in between, and the pollutants, instead of being able to flow freely up, end up being pushed down. And this leads to smog and other pollutants, just trapped pollution. Here's a video of this occurring in an area of mountains. And I want you to know, when you're looking at this, what you're seeing here is pollution, not clouds. You will see the clouds on the top in a minute. So there are my clouds right up here. You see them? All of this down here is pollution. That's being trapped due to temperature inversions. And you'll be able to see it more as he scans. You could clearly see the sky is all the way up here, and that is trapped pollution. So that's what happens. It traps the pollutants and causes a mass area of pollution. Ozone. What do we know about ozone before today? Where is it? It's in the stratosphere, and what does it do? Protects. But ozone can also be found in the troposphere. And in the troposphere, it's actually a toxic chemical that we don't see or smell, but it's highly reactive and toxic. And like most pollutants that are in the troposphere, they're going to damage crops and cause respiratory problems to your health. And here's a little diagram stating bad ozone in the troposphere versus good ozone in the stratosphere. Covering the major outdoor air pollution problems, and then we'll go to indoor. What are they? Smog. The ozone hole. Acid rain. Global warming. Good. As a review, what's the main source of air pollution problems? Chemicals or primary pollutants? Transportation. So transportation is going to lead to the release of nitrous oxide, sulfur oxides, volatile organic compounds, particulate matter. It's not going to lead to ozone, okay? But when these compounds and ozone react in the troposphere, smog forms, okay? So our nitrous oxide, sulfur oxides, volatile organic compounds, and particulate matter, and carbon dioxide and carbon monoxide are produced from cars. But these compounds, so no carbon dioxide and no carbon monoxide, plus ozone, produce smog, which we talked about yesterday is like smoke and fog, okay? It's like a foggy, a polluted fog. That's what smog is. And I want you to know that it's, on the AP exam, this has come up, LA had a big problem with smog. It's on my next slide, but write the word LA so you know when you see a state in the United States that was highly linked to smog, it was Los Angeles. They actually did studies as of how many kids miss school a year and have health-related issues or respiratory issues because of smog. And then they did something about it. So we always refer to acid rain, not acid deposition, but the reason you have this name is because it can come down as rain, fog, snow. So really acid precipitation would be what we should be calling it. But it also comes down as dry particles, so it's called acid deposition. What starts it? What's my starting compounds? Sulfur and sulfur reacts with water. What else can react with water? Nitrogen or nitrous oxides and sulfur oxides react with water to form what? And? Correct. It's not and, it's or. So you can have sulfur compounds in the atmosphere that react with water and they form sulfuric acid, or you can have nitrous oxides in the atmosphere that react with water and form nitric acid. What forms are sulfur compounds? Let's review that. Volcanoes. Weathered rocks, but not in excess. Fossil fuels, which one? Coal, okay? Coal is my main producer of sulfur in the atmosphere. Remember that sulfur is produced in the atmosphere naturally through the cycle. Why is sulfur in excess is what you want to think of when you think of pollutant. And pollution, excess of chemicals is going to come from things that we did that we didn't do before in the natural cycle. And pulling coal out of the ground and burning it is one, okay? And what about nitrous oxide? What puts that in the atmosphere? Excess what? Use of fertilizers. What else? Burning biomass, okay? And burning fossil fuels. Now, anything below a 5.6 is considered acid deposition. So normal rainwater would be 5.6, but below that is acid. And then we've got pure water in 7. So anything in that range is good. 5.6 or below is acid deposition. When you think of primary pollutants, pollution or major pollution problems, try to keep in mind that plants are going to be a big target to being affected by these pollutants because we have a lot of defense, whereas they don't, okay? So single-celled organisms or plants that take in these chemicals directly are going to be highly affected. And any aquatic organism can also be affected through acid deposition because it's going to fall on land or water. So it's going to be absorbed by the soil, which is taken in by plants. And when it falls on water, all aquatic organisms will be affected because the pH of their environment changes. And that's just a graph showing you what levels they can live in. You don't have to know that. All right, so three major things I want you to know about air pollution. Any air pollution inside your home is going to be greater than outside. Why? Because it's confined. It doesn't have a way to dilute or mix or move. It's kind of stagnant. And because we spend more time inside, that's another reason. Okay, so we're more affected. So apart from it not being able to move, we're more inside. And this fact here, when you're in your car, the pollution is greater inside your car than it is outside, even during heavy traffic. Okay, that's a fact. Everything that's outside is coming in your car, and you can't escape it. Okay, so think about that. So now we're going to learn about the 4 most dangerous indoor air pollutants. What are they? Well, tobacco, because carbon monoxide will lead to death if it's indoor. So it's linked to carbon monoxide, right? Because we know cigarette smoke emits a certain amount, but tobacco smoke is one of them. Dust, good. Particulate matter, let's call it that. Small particles or particulate matter. Anybody know what's found in furniture or what this compound is here? No? It's called formaldehyde. Formaldehyde found in furniture, paneling, insulation, and then radon. Radon is actually found in your ground, in the foundation, so that what builds or holds your house up, in there's a radioactive chemical called radon, and it seeps into your house, and it's considered one of the most dangerous indoor air pollutants. In addition, we have this chart, which, I mean, it doesn't hurt to look at. I'm going to narrow it down for you of what we have to know. Asbestos is a big topic of indoor air pollutants. This is one of the other things that was completely wiped out. Asbestos is a form of, it's a compound found in insulation. All public schools had asbestos. That's how they were built. So insulation is what's in between your walls to do what? So keep warm or cold is the idea, but really what's it doing? Which does what? Helps what? No filter. But by keeping the temperature inside your house that you're trying to maintain, you're doing what? Increasing what? Efficiency of a system. The insulation. So if FPL came to do an energy audit in your home as to why you're paying so much money, that's one of the first things they're going to check. Leaks in your windows, so loss of energy, or poor insulation, which is supposed to be helping you maintain. So that was a compound found. They had to, basically, I lived through this. In 1988, my school was shifted from building to building so they can go in and remove the asbestos from the walls. They had to redo the walls. So that was a full removal. We know about carbon monoxide. We've already done it. We know about tobacco. Radon, as I said, radioactive chemical in your soil. We don't have to know this one for now, this one for now. We already did this one. We don't have to know this one for now, or this one, or this one, or this one. We already did this. Nitrous oxide comes from the burning of fossil fuels, and all those are related. And particulate matter, you know what it is. Because it's linked to formaldehyde. You don't have to know that on the test. All right, so we're here. More indoor air pollutants. What are these? Dust mites. What else? Mold and mildew, which is like almost the same thing, which leads to sick building syndrome. A lot of people that have mold in their home don't even know about it, and they're constantly feeling fatigue or dizzy or have a headache, and it's because they have mold in their home. Not to mention, if it leads to respiratory problems, then that eventually can go to your lungs. All right, so as I mentioned in the last unit, for now, we want to know that all these acts occurred in the 70s. Okay, so environmental awareness started to take place around this time, that we were drinking unhealthy levels of water, we were swimming in lakes that were unhealthy, and our air was unhealthy. So the Clean Air Act basically set standards on how much emissions can be produced in a specific area, and they target industry. Industry can only emit specific amounts of each compound depending on the industry, and if they're going to go over, they have to buy from another company that's not using. Okay, I'm done. So lead doesn't break down, doesn't dilute, big problem, leads to cancer. Gas used to contain lead.